Good morning, everyone.
Good morning.
Morning.
Question, I have a fan going on right now. Can y'all hear that at all? Like, do you hear a background noise?
No.
No.
Cool. Means I get to
Not
be
really.
and teach. Yay.
Question.
What's up?
Did we have class Monday?
No, we did not. It was a university holiday.
Oh,
Fix
I
that
thought it-
in Blackboard as well. Whoops. I think that's the YouTube for my 140 class. Yeah, ignore that link. I don't know why I still have that copied. And you're welcome to go watch that. It was covered in my Math 140 class this morning, but there's a link for poll everywhere. Janelle, sorry, I think I kept talking. I didn't give you a chance. Did you say something else?
No, I was saying I think I misread your something you wrote on Blackboard. I thought you said we did have class. I thought that's what I said.
Yeah, I messed that up on Blackboard. It was like, if you look at the weekly learning module, it said like before class on
Yeah.
that day. Yeah, it did say that. I fixed it, but that was sadly after our supposed class time on Monday. But yeah, no, we had no class. We're covering all the material this week. I have to figure out what we're going to do for next week because I can't miss a class, but I'll tell you. Oh, cat. Sorry, I got distracted. Oh, and it's 10 or 11:01. So there's the link. Let me activate the quiz. So daily quiz is now up on poll everywhere. I'll give you all just a couple minutes to type in your answer. Let me share it. So daily quiz, what is the derivative of the function f of x, which is natural log of x squared? Natural log of x squared. So some people come in at the last minute, so there's the link one more time. Whiteboard. Trying to find the derivative of the natural log of x squared. All right, let's see. Got more people in here. Last time I am posting that to the chat. All right. Let's see, 17 of 25. All right, I'm just going to give y'all one more minute. Finish this. We've got well over half the people have submitted answers, and good answers so far. So make sure you get your answer in. Whoops, Bevy, wrong place. Did you get it?
Morning.
What's up, Sonica?
I just logged into class a little bit late.
Okay.
And I only have how much time do I have left?
30 seconds.
Damn. Okay, cool. Thank you.
At least get in best guess.
Okay.
Got most people in. So I said 30 seconds. Actually be legit with the clock. 15 seconds left. Gotcha. Give me 5, 3, 2, 1. Going to lock answers now. 1 second. Okay, now locked. Should have gone through. I was trying to give y'all just a couple more seconds. All right, so derivative with respect to x of natural log of x squared. If you wanted to take the derivative as is, you have to use chain rule. All right, take the derivative of the outer function, which is, gotcha, Zante and Bevy. Take the derivative of the outer function, which is natural log function, which is derivative of natural log is 1 over x, and I replace that x with what is inside. So it'd be 1 over x squared times the derivative of what is inside, which is x squared, or 1 over x squared times 2 to the x. And I can simplify this because I'm multiplying by an x and dividing by an x, so 2 to the x over all. So this is how you would have gotten this derivative if you just taken it as is. There is a nice log rule that you could have used at the very beginning that would have made your life much easier. No chain rule needed. Anyone know what it is?
Product rule?
Not product rule. Well, I heard product rule. I'm not sure if that's what you said. So there's this rule with exponents. Right, rules with exponents and logs. I can take the exponent and bring it down out front and multiply by it. So natural log of x squared is the same thing. Yeah, so kind of power rule. Power rule might be not a bad way to describe it. But we take that exponent down out front. So natural log of x squared is the same thing as 2 times the natural log of x. So then I pull out that constant. And I'm just left with the derivative of natural log of x, which is just 1 over x or 2 over x. Another way you could have gone about it. Okay. So I know when we're doing all of these examples, I don't get enough time to really harp on this fact that you can rewrite functions before you take the derivative. Right? It will make your life much easier. Something that you saw in a couple homework problems. Right? You don't have to always just go straight into product rule, straight into quotient rule, and same thing with these natural logs. Right? If I can rewrite this to make my life a little bit easier, might as well do it. But there is absolutely nothing wrong with just taking the derivative as is, right? Nothing wrong with that, just sometimes sets you up for a little bit more work to do. Okay? Questions, and if not, please give me a thumbs up. Questions, questions, questions. Just seeing thumbs up. All right. So today we're talking about critical points. And critical points are pretty easy or relatively easy to find, and it's one of the uses of our derivatives. And critical points are just values of which we usually call C, such that Our derivative is equal to 0. These are critical points where my derivative is equal to 0. And once we have these critical points, especially if you watch the videos, these describe where my function stops increasing or stops decreasing. So for example, let's draw it in blue. Something like this. I would have two critical points for this function. One would be right here. Another one would be right there, just to differentiate them, C1 and C2. Because where my derivative is 0 is where my tangent lines would be flat. And I see that I get a flat tangent line right there and a flat tangent line right there. Right? So this is where I'm going to either get values that will show me I have a relative max or relative min, and then potentially also an absolute max or an absolute minimum. But the first thing we want to do is practice finding these critical points. So really, it's just what we've been practicing, finding derivatives, but then I have to add in an algebra step at the end of it. Set it equal to 0 and solve. So you have a new question up on poll everywhere. I'm giving you the equation function f of x, which is x cubed plus 15 halves x squared plus 18x plus 2. I want you to find or list the critical points. I just want the numbers. Don't care about what order, anything like that, just the numbers that are the critical points. Just separate them like with commas like you would in WebWork. Okay. So then, I'm gonna give y'all, I'm gonna say until 10:14, which is just under 2.5 minutes from now. So we can make sure we're moving along, doing more examples. So about 2.5 minutes. So 11:14 AST. I forget I'm on Eastern Standard Time right now. All right, so let me, now that most of y'all are working on it for the recording, let me share screen so we get the function. You don't just have what I read off. So list the critical points of the function f of x. X cubed plus 15 over 2 x squared plus 18x plus 2. Cool. So I'm gonna say I'm getting a lot of answers in 30 seconds. 30 seconds left. Good answers so far, everyone. We'll lock answers here in 5, 3, 2, 1. Locking answers now. All right, so half y'all are getting through this, which is good. Remember critical points. Find the derivative, set it equal to 0. Those values that make my derivative 0 are going to be my critical points. Debbie, I just saw your response. I'll get you here in a second. So I need to first find the derivative of this function. Find the derivative of x cubed plus 15 halves x squared plus 18x plus 2. And hopefully you're feeling very comfortable with doing derivatives of polynomials. I just have to apply the power rule to each part. This will leave me with 3x squared plus 15x plus 18. Take each of those exponents, multiply it by the constants for each term, and then subtract 1 from the exponents. So then, like I said, to find the critical points, take that derivative, whoops, 3x squared plus 15x plus 18, set it equal to 0 and solve for x. Those are going to give you my critical points, which we usually denote with a C. Well, if I look at that polynomial, they each have a common factor. What is the common factor that each term has?
3.
And it has a 3 in common. So I can factor out a 3, and this leaves me with x squared plus 5x plus 6 is equal to 0, which I could technically divide by 3, which tells me then, or I can just go ahead and factor that polynomial, because really what matters then is when x squared plus 5x plus 6 is equal to 0, but that's going to be equal to 0 when x is -2 or -3, because it factors into x plus 2 times x plus 3. So then this gives me, just to write it out, ooh, that's bad, or worse than usual. So my critical points are -3 and -2. Just to make a note, some of y'all went ahead and plugged in the values. So plugged in C, that is kind of the next step that we do for these types of problems. And it's a little, we can kind of see it a little misleading as points, right? When we think about points for a graph, you're thinking about an X and a Y value in ordered pair. But really critical points are just the specific X value. That's all we really care about for critical points. Okay? So if you went ahead and calculated f of -3 and f of -2, you probably got the right answers. I think they are f of -2, I think it's -12. F of -3 is what, -23/2, I think, yeah. That's extra work for finding critical points, not necessary, but just want to let you know that you're still good. Okay? Critical points are just talking about the x values where my derivative is equal to 0. All right, stop talking. Thumbs up if you're feeling good. If not, or if you have a question, please ask it. The critical points are just taking derivatives, set it equal to 0, and solve. All right. I'm just seeing thumbs up. All right. So, like we said, we're going to have critical points. And with those critical points, we always are going to be able to test, well, if it's an absolute max or an absolute min. So, the easiest way to find an absolute max or an absolute min, and this is always going to be on an interval. Some interval, AB. Right? First thing you do is find critical points. Second thing you do is find the y value of those critical points. Whoa. And third thing you want to do is find the y value of the endpoints of your interval. That is your A and your B. So find out what happens when I plug C in on my critical points. And I also want to find f of A and f of B. This is a nice, easy way to find it because then I look at all of those y values. If I want to find a max, when I look at that list, I say, okay, what is the largest y value that I see? That's going to be my max across this interval. If I look for find the lowest y value, that's going to be my min. And if you kind of take that basic example graph that I drew before, so something like this, right? What we're saying is if we take some interval AB, we just restrict ourselves to looking at that interval, I do have a critical point. There's still going to be a critical point in there, and I can see just visually at that critical point, that is where I'm going to have a maximum, right? But where am I going to have a minimum? Well, it depends on what f of A is and f of B is. One of those two, whatever the lowest y value is, that's going to give me my minimum. I see it occurring at an endpoint. And I could rearrange this to where my critical point is going to give me a minimum and my endpoints are giving me a maximum. That's what we always have to test, depending on your intervals. And sometimes your intervals won't include any critical points. If I drew that same picture, let me just go to a new slide. Let me not try to write it down there. I drew that same picture and changed up my interval and said I'm only going to consider between those two y values. That means anywhere along this part of my graph, right? Would I have any critical points there? Do I see anywhere where I'd have a tangent line with a slope of 0? Yes or no? The answer is no, right? I don't see any around it. If I drew tangent lines for any part of my graph where I just kind of scribbled that red over, it's always going to have some slope. It's never going to be 0. So on this part of my graph for this specific interval, I'm not going to have any critical points, but does that mean I have no max or min? No. Right? I still have a max and I still have a min. It just occurs at those endpoints. That's why we always need to make sure we test our critical points, because that's if we find them and they're in that interval, there are going to be options for a max or a min. And then if we also, or just based on these visual explanations, we also need to make sure we test the endpoints of our interval, because the max or min might be occurring at those. Okay. So quick question, any quick questions before I put up the next question on Poll Everywhere? And I talk for a moment. Oh, I'm seeing a couple thumbs up. All right, so next question is up on poll everywhere. Next question is up on poll everywhere. So we're going to come back to this screen on Zoom if you want to have it while you're working on it. We're working on this problem. I'll share the question to Zoom here in a second for the recording, but I want to make sure y'all have both of these sources available to you. Oh, and that's one last thing, just while you're doing this. When we say maximum value, it's always referring to the Y value. What is the largest Y value that you achieve? Or minimum value? Again, it's just the Y value, the smallest Y value that you achieve. So we don't need, though the points are associated, we don't need, when we're asking the question maximum or minimum value, we're not looking for the X value that's associated with it, we're just looking for that output. It's one other note that I wanted to make. All right, I'm going to say at 10:30, so I'm going to lock all answers. So 2.5 more minutes. 2.5 more minutes. All right, so now I feel comfortable sharing the screen. So this is for the recording. We're trying to find the maximum value of the function 2/3 x cubed plus 1/2 x squared minus 4x plus 11 on the interval -2 to 3. Like I said here, note the maximum value refers to the highest y value achieved. What is the highest y value that you achieve on the interval -3 to 2? All right, so I'm gonna give you all, just because of the number of people who responded so far, maybe I'll just 1 more minute, finish entering answers. 1 more minute to finish entering answers. All right, so I'm going to lock answers here in 10 seconds. I want to make sure that we're moving along. 5, 3, 2, 1. Locking answers now. For the person who submitted just 5 dots, thank you for submitting something. Okay? I want to know where you're at, which means you are lost, which means I know that I need to put in more explanation here. Okay? But make sure you're watching the videos before coming to class. I can be that person and say technically you had all of Monday to watch the videos, but I'm not going to say it explicitly. So when we want to find the max value, we just do the same process. We want to find critical points, right? So find the derivative, set it equal to 0. That's the first step. Then after that, it's just plugging in to find y values for my critical points and my endpoints. But the thing here is I want to make sure that I'm only considering x values between -3 and +2. Okay? Only between -3 and +2. So I take the derivative of this function. I'm going to get 2x squared plus x minus 4. 2x squared plus x minus 4 is going to be the derivative. So then I set this equal to 0. And then I try and solve this. Okay? So I factor this thing.
No, you can't factor it.
Can't factor it right off, right? So this is still a quadratic, which means I can use what to find the roots?
Negative
Quadratic formula.
Yeah, quadratic formula. Right? I think I saw Chevy mouth it as well. Right? Quadratic formula is what I got to use here. B squared minus 4ac all over 2a. Or square root b, negative b plus or minus b squared. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So this will be -1 plus or minus the square root of 1 squared minus 4 times 2 times -4. Well, let me just rewrite all of that. All over 2 times 2. Which means this is -1 plus or minus the square root of 1. Well, let's see. We would have 4 times 2 is 8 times -4 is -32, but I'm subtracting it. So plus 32 all over 4. Please don't hesitate to speak up if you see me do arithmetic wrong. I'm doing this off the top of my head. Which means then that my x's that make this true is -1 plus or minus the square root of 33 over 4. 1 plus or minus the square root of 33 over 4. I can't reduce 33 because that's 3 times 11, which are both prime. So we're kind of stuck there. So this is where calculators come in handy, because I need to figure out, okay, are these between -3 and 2? So I just go punch in a calculator and say, hey, what is -1 minus square root? I'm literally doing that right now. 33, all of it divided by 4. So if I do -1 minus the square root of 33 over 4, this is approximately -1.686. Now I'm not using that value. I'm not going to use -1.686. I'm just trying to get an idea of whether or not this is in that interval. Is it between -3 and 2? Is it between -3 and 2?
Yes.
Yes,
Yeah. -1.686 is in between -3 and 2. And we're caring about values between -3 and 2. So that works. And I want to figure out, okay, well then what is -1 plus the square root of 33 over 4? Again, I just go to a calculator and say, okay, what value does that give me? Is it going to be in between -3 and 2? You plug this in, you get a positive approximately a positive 1.186. Again, I have to ask myself, is that in this interval, -3 to 2?
Yes again.
yeah.
Yeah, it's between -3 and 2. So I need to check both of these critical points because these might give me an absolute max. So I only not check my critical points, but what were the other 2 points that I need to test? Someone other than Zante, because I know he's here and responding.
The interval.
Yeah, the interval, the endpoints. So I also need to check -3 and -2. So to find max, we need to check f of -3, f of, whoa, why did that switch to green? -1 minus square root of 33 over 4, f of -1 plus square root of 33 over 4, and then f of 2. I just need to use a calculator here. This is why I'm still letting y'all have scientific calculators, because a lot of the times these numbers aren't going to come out to be nuts. Okay. Well, if I plug in -3, I'm going to get that this is 9.5 or 19/2. Okay, then I plug in that second one. So -1 minus square root of 33 over 4. When I do that, this gives me 15.97022.015. Just giving myself a lot of decimal places there. You can round, but I want to be exact as possible, and this is supposed to be an exact second. Plug in -1 plus square root of 33 over 4, you're going to get 1.8 or 1.18614 614, 0, 662. And then if I plug in 2, I'm going to get 31/3, which is approximately 10.333. And if you remember this notation, that little line over a decimal just means you keep repeating that. But all I have to do is, once I find the critical points, plug them in and figure out, okay, of these values, of these 4 values, what is the largest y value that I see? What is the largest y value that we see?
The 15.9. Yeah. I remember.
Yeah, that 15.97 blah, right? That is the largest y value that we see. So the maximum value for my function on that interval, -3 to 2, is 15.970222015. So that is my maximum value, right? So, questions so far? Feels like a lot, but really we're just kind of adding on, we're taking the calculus that we're learning and now applying again some of our algebra. Let's see if I can pull up Desmos too. But any quick questions?
Hello?
Oh, you there? What's up?
Hear me?
Yep, I can hear you. What's up?
Okay. So my question is this: will the answers always be either factorable or be able to be put in the quadratic formula or equation? Yeah.
So it depends on the problem.
Would be it.
Like we're just doing polynomials. I'm giving you cubic polynomials because that's kind of when you take the derivative of a cubic, it goes to quadratic. And we've trained you through all of your algebra courses to be very familiar with factoring quadratics, right? So we're trying to at least make sure that you are kind of in a comfort zone, so to speak, when it comes to solving for zeros. But that's not always the type of functions that you need to have or have to have. So just to put it out there, so let me change this from -3 to 2, just so we get a visualization. Oops. Real quick, share screen, projector mode, get that out of the way. So we were considering all values between -3 and 2. And we said that we achieved our maximum value, which was 15.97. You can see is about right there. And when I plugged in, that it was when I plugged in the -1 minus square root of 33/4, which we have found to be kind of close to that -1.68. So this isn't maybe the exact point. This is just to show you that, yeah, visually, once I graphed this thing, that was where from -3 to +2, that is the highest value that this function achieves, right? Oh, wait, it didn't share. Crap. Now it's sharing. That's the point I was talking about. This is a graph I was talking about from -3 to 2. We see that the largest value for the graph on this interval that we see is that 15.97. When we plugged in that -1 minus square root of 33 all over 4, so it's approximately that. This calculator is just giving me the approximation. Okay, so that's just your visualization. Any quick questions?
Yeah, I have one question. When you do f of -3 and you get 19/2, you plug the 3 back into the formula? How'd you get that?
Yeah, so this function right here. So here, we can use define f of x is equal to, and then you do f of 3, or -3, you get 9.5. So you just want to plug all those points, all those critical points back into your original function. Right? That is something that happens a lot. Don't plug them back into your derivative. Derivative tells you your slope of your tangent lines. That's all the information is going to tell you. If we're trying to find the maximum y value, we want to plug it back into our original function, the function that we're studying. Good question. Thank you for asking that question, Chevy. Any others? All right, let me stop share. So we got 5 minutes.
So you say once you find the critical points, you just plug it back in the equation and then you find the maximum.
Sorry, I was having trouble hearing you. Can you repeat that?
No, we're just repeating what you were saying to make sure. You said once we find the critical points, we bring it back into the equation and that gives us the maximum, the max. Yeah.
Yeah. I apologize. I'm having trouble hearing you, but I'll repeat it as well. So the overall process, right? Find your critical points. I think I heard you keep saying that. So find the critical points. That's when you find your derivative set equal to 0. Right? Once you have those critical points, those are x values. You're going to plug them into your function, your original function, not the derivative, into your original function. That's why we were doing, like you saw on the calculator, you plug it into that. For this case, 2/3 x cubed plus 1/2 x squared minus 4x plus 11. Right? And then also make sure that you plug in your endpoints as well. And then just look at your y values to find your largest y value.
Okay, thank you.
Yeah, pleasure. Sorry I was having trouble hearing you. My volume's up all the way, but it's probably my computer. But that's always the process. Set it equal to 0 and solve. So the last thing I want to cover, which is from 3.4, is the mean value theorem. It's this wonderful, wonderful statement. It's kind of one of your biggest theorems that we cover in calculus. And really what it just says is that your velocity, your average velocity over your entire interval, whatever it is always going to be achieved at some particular point. So if you watch that last video on mean value theorem about a car traveling in between toll booths, and they say, well, you actually had to speed at some point along the path. That is part of the use of the mean value theorem. We go back to Desmos, and I want you to just do the calculation for me. And we want to find said C, and it's that we're given the function. Actually, we probably won't have time to do it, so I'm just going to go through the examples. If you want to work along with, try to work ahead of me, you're more than welcome to. Okay? So our goal is to find a C, some value C, in the open interval -1 to 1, such that when I take the derivative of this function and plug in this particular value, this is going to give me the average slope over that entire interval. So, and this is where, this B and A are represented as the endpoints of my interval. So you see it in the statement of the mean value theorem, this AB, A is the left endpoint, B is the right endpoint. And we're given that our function, f of x in this case, is going to be 3x squared minus 5x minus 12. So I have to do a couple things. I need to calculate what this right-hand side looks like, f of b minus f of a over b minus a. And I also need to find out what the derivative is supposed to be, and then set it equal to that value. So let's first find f of b minus f of a over b minus a. Well, f of b means the right endpoint. So when I plug in 1, so this will be 3 times 1 squared minus 5 times 1 minus 12, which would end up being 3 minus 5 minus 12, so negative 14. My f of a is my left endpoint, which is -1. So this would be 3 times -1 squared minus 5 times -1 minus 12 would be 3 plus 5, minus 12 should be a negative 4. Again, I'm trying to do these calculations really quickly, so if you see the arithmetic mistake, call me out on it. That's okay. But now I just need to plug these in. Okay. So f of b minus f of a over b minus a would be negative 14 minus negative 4 over 1 minus negative 1, which gives me a negative 10 over 2, or a negative 5. So that negative 5 is giving me the average slope for this function over the interval negative 1, 1. And I want to find out what point of my function, what points, or between negative 1 and 1, is my derivative of my function going to match up with that average value. Okay? So I need to figure out when my derivative is equal to 0. I'm going to have to go to a new board, but I'm going to have to go to a new board. I'm out of time. But the goal, let me just write it here, f of b minus f of a for this problem over b minus a was negative 5. F of x is 3x squared minus 5x minus 12. So then the derivative is going to be 6x minus 5. So I set my derivative equal to that value that I'm trying to find, which is negative 5. So set 6x minus 5 equal to negative 5. And then solve for x. That's going to give me that value where my derivative is going to be equal to my average value. So then I would have 6x is equal to, well, I add 5 to both sides, which is 0, which then tells me that that x value is 0. And then to sum it up, so that value 0, c being 0, is in between negative 1 and 1, and f prime of 0 is equal to that f of b minus f of a over b minus a, which is equal to that negative 5. Okay, so when x is 0, that is when my average slope, when my derivative of my function is equal to the average slope over the entire interval of negative 1 to 1. So that's mean value theorem in a very, very, very quick example. That's all I'm expecting y'all to do on the homework. Yes, again, just instead of finding a derivative set equal to 0, finding the derivative, setting it equal to your average slope over the interval. Okay. So, questions? If not, thumbs up. Cool. I'm seeing thumbs up. Thank you all. All right, 10:53, well over time. If you need to go, go. If not, you're more than welcome to stick around. I'm going to go ahead and stop the recording though now.